The last speaker before the lunch is Michael, and he's going to tell you something about the history and future of the markup.
Yeah, hi, I'm Michael, and this is likely to be the least technical talk of, at least of this XMLPrague. But listening to the previous two presentations, I think it fits in quite well at this point in time. So last year at XMLPrague, we celebrated 20th anniversary of XML. And some people, I've got the T-shirt, and many of you certainly have too. And some people may ask, so what? Because for data, the cool guys now use JSON, as we've just heard. For documents, the cool guys now use Markdown. And on the web, we now use HTML, which looks like SGML, but is neither SGML nor XML. So some people conclude XML is dead, baby. Or maybe not. I'm preaching to the choir here, of course. The report of XML's death has been greatly exaggerated, as there are hundreds of specifications and standards built on XML, dozens of related technologies, many of which have already been mentioned during XMLPrague, from XSLT to XForms, XQuery, XPath, you name it. And of course, at the height of the XML hype, XML found its way into so many applications, from configuration files to Office documents, spreadsheets. It's been mentioned several times. It's unlikely to completely disappear anytime soon. So what Tim Bray said on the occasion of the 10th anniversary of XML still essentially holds true. There's essentially no computer in the world, desktop, handheld, or backroom, that doesn't process XML sometimes. But I believe it's nevertheless a good idea or a good moment in time to reflect about the history of XML from where we are coming, in order to think about where we should head. For many people nowadays, technological progress is something that goes in one direction. Everything is getting better and faster and smaller all the time. But it basically remains the same thing as in the case of the iPhone, where for many people the next big thing is just like the latest thing, which is basically just like the previous thing. And so past, present, and future all collapse into a single point, what Brian Eno called the short now, where there is neither a past nor a future. It's all just the present. But I believe if we want to go forward, we need to know where we came from, including perhaps knowing about the roads not taken, about wrong decisions, about decisions that turned out to be right after all, and so on. And one interesting thing when you consider history is that software is a very peculiar class of artifacts, because the laws of physics don't apply to software. So software designers enjoy, for better or worse, almost unlimited flexibility. In other words, there's no need for the software we use now to be the way it is. It could be totally different. And most importantly, software are cultural artifacts. So they are not natural things, they are cultural artifacts. So there is no natural selection or survival of the fittest. But it's determined by other factors, by cultural and societal factors. So in this vein, I'd like to say a few words on SGML and XML, mostly SGML, just for as historical predecessor of XML. The year's history photo of the famous SGML stamp that was in use at the big academic publisher where I had my first job after graduating, SGML rubber stamp. Also a nice historical artifact. Now, the history of XML is well known, and I guess most of you, or most attendees of XMLPrague know at least some of it. It's well known that XML is based on SGML, and the history of SGML is also well known, also because Charles Goldfarb has recounted it many times at different occasions. So, for example, in 1996, he basically summed it up like this: after the completion of GML, I continued my research on document structures, creating additional concepts such as sort references, link processes, and concurrent document types that were not part of GML. By far, the most important of these was the concept of a validating parser that could read a document type definition and check the accuracy of markup without going to the expense of actually formatting a document. At that point, SGML was born, although it still had a lot of growing up to do. Interestingly, many of the concepts that Goldfarb added at this time are precisely those concepts that were removed by XML. Practically all of this. And I'd like, in the sense of, well, software doesn't need to be the way it is. It can take many different shapes. I'd just like to briefly mention some observations on SGML. It's a bit longer in the paper, but I don't have the time here. Luckily for you, this is just a the short talk. So, just some random things on SGML. There are other things that could be mentioned. So first of all, of course, SGML has not been the only attempt to standardize document representation. There may be two or three people who remember ODA, the Office Document Architecture, ISO 8613, but not many. This was exactly, I had you in mind. A very different approach, which also goes to show, well, there are different ways to do the same thing. Also, as Robin Kever mentioned in 1993, SGML has had significant intelligent detractors from the beginning, and the criticism ranging from using embedded markup at all to all kinds of other things. It was not uncontested. Not everybody agreed that SGML is the way to do it. And then, of course, SGML is an extremely complex standard, even though it looks pretty thin. But actually, in that form, it's basically not understandable without Goldfarb's commentary. And Stephen D. Rose has noted that the list of SGML complexities that do not add substantial value is quite long. And this is certainly true. And now, from a historical perspective, some of these complexities are easy to explain, whereas others are not so much. I mean, for example, one of the best-known features of SGML that were removed from XML is markup minimization, so that you could omit end tags, but also store tags, quotes around attributes. But the minimization features are actually much larger and include data tags, which is data that can also serve as tags at the same time. These kinds of things are clearly motivated by reducing the amount of typing you have to do if you're manually entering an SGML document. So that thinking is clear and can be explained by the circumstances. But other things are not so easy to explain. For example, SGML has no idea or no concept of processing SGML documents except for validation. This is basically the only thing that's in that standard. You can validate a document, and determine whether it's valid. And that's basically it. And so already back then, there was criticism such as this one. SGML is a passive standard. The SGML standard refers frequently to the application, but includes no clean mechanism for attaching applications to SGML parsers. You guess this is kind of surprising if you think of the background of SGML in GML, which is a text formatter, where you have a very clear intention. Okay, you want to print a document at the end, so there needs to be some processing. But this is absent from SGML. Another interesting observation in SGML that is really strangely detached from computer science terminology and concepts, both terminology and concepts. And there's also here's also kind of contemporary, quasi-contemporary quote. Since SGML is a language intended for computer-based systems, it is reasonable, in the absence of convincing argument to the contrary, that it should follow established conventions within the realm of computer science. And these kind of comments specifically target the issue that you can't use LEX and YAC to build an SGML parser, because it does not fit into the normal grammar hierarchies that are known in computer science and whose complexity is well known. But you can't use this. And there is no clear technical reason for this. Another final observation is that it was clear to the editors of the SGML standard that an SGML document describes a tree. And here's a quote from Goldfarb. To that extent, SGML can represent documents of arbitrary structure. It does so by modeling them as tree structures with additional connections between the nodes. Yet, if you look at the standard, it's almost exclusively focused on syntax. It's syntax, syntax, syntax. You can configure the syntax in multiple ways and do all kinds of things with the syntax. But the conceptual structure, the tree, is almost never mentioned. So SGML is a cultural artifact, and to the best of my knowledge, there are no good, that is, technical, objective reasons for these properties of SGML. So as mentioned shortly before the creation of XML, the historical origins of SGML as a technique for adding marks to text has left legacy of complexities and difficulties which hinder its wide acceptance. So that was briefly before XML appeared. Just as something to think about, a piece of counterfactual history, imagine if Charles Goldfarb, who worked for IBM, had met Mike Collishaw, who also worked at IBM and so known as the author of the Rex scripting language, and they would have met and integrated Rex into SGML as a language for tree manipulation. Just counterfactual history. I think things would have certainly turned out quite a bit different from what it was. And now the statement by Price was proven true by XML. It's quite fascinating historically how quickly it was adopted and how an extremely rich ecosystem developed once many of these complexities had been discarded and gotten rid of. Now this, well, SGML reflects thinking from the 1960s and 70s. Texts are not supposed to vary while being read. Now, what's the future? I don't know, of course. But here's just another observation on HTML5, which kind of looks retro in that it adopts a quasi-SGML notation. But if you read the specification closely, you find that it's actually something it's something completely different. And HTML5 is more like a literal syntax for describing a particular JavaScript data type, a kind of here document for the tree data type or for a DOM data type of JavaScript. To conclude, because time is up, XML has come a long way. It's the result of 50 years of work on markup and document processing. And some choices were made consciously, while others less so, and some features can only be described as historical accidents. As I just mentioned, despite its retro appearances, HTML5 is conceptually quite different from HTML and XML. And I think you really only notice this in the comparison. If you just read the specification without that, of course, you can understand what it does, but it's hard to see the historical development. Whether it's a good one or not is something, it's a different question. Michael Spurbeck McQueen said in 1992, part of HTML's accomplishment is that by solving one set of problems has exposed a whole new set of problems. I think that probably goes for XML as well. And by consequence, the design of new markup languages, now in a wide sense, is like that of programming languages, and I'm citing Mike Collishaw, again, always subtly affected by unconscious biases and by historical precedent. In other words, those who cannot remember the past are condemned to repeat it. Thank you very much.
Michael, thank you very much for this refreshing talk. So do we have probably not questions, but additional comments? Anyone? Over there.
From the left side.
Mike.
Agree with everything you said. I think one thing missing is the impact of commercial decisions and the way XML took off because of the open. It coincided with, other things like the open source movement and brought the costs of adoption down. And a lot of this has to do with cost of adoption, which is partly price of software and partly availability of tools and availability of skills and all those sort of things.
Absolutely, yeah. I just focused on a few isolated things, but of course you have to consider the whole time, and the discussions around discussions and development, parallel development, the web, obviously, and everything else that was going on at the same time. So it's and that's certainly good that you mentioned that, because that can have a huge effect on the choice of technology.
I noticed that the title of your talk is History and Future of Markup, and a very interesting history, I think, of where things are coming from and where they've got to. But you haven't said a lot about the future. I wonder whether you could say a bit more, based on the history that you have discovered. Would you like to predict the future?
Well, predicting the future is, well how does that saying go? Predicting the future is hard because it's obviously quite difficult to say. I think one thing, of course, that we can see is that it's not necessarily objective technical reasons for one technology to prevail over the other. And you can certainly say that, well, if you ask, is JSON better in an absolute sense than XML? Well, probably not. Is Markdown better in an absolute technical sense over XML? No, certainly not. It removes lots of things. It's interesting in both cases how how syntax, the visible aspects, are still very much influencing people in their decisions. I mean, an XML document and JSON file representing the same tree structure, nowadays this is well known, but still people say, oh, these angle brackets, I can't stand that. And so I think these cultural aspects are very hard. I think what's really making it very hard to predict, because you could certainly predict technical requirements from the things that you see. Of course, dynamic, more dynamic processing, and interaction on mobile devices and all these kinds of things are relatively easy to predict, but it's very hard to predict these cultural things. So that's my non-prediction.
Oh, there is one last question over there, upstairs.
In your talk, you focused especially to the web, the HTML and XML comparison. Did you consider looking at document formats used in publishing, for example, Word documents, InDesign documents, because most of the formats are stored in zip containers and there is XML inside. So I see this the last couple of years, lots that document formats focus or are based on XML technologies.
Yeah, well, that is, yeah, you're right that I've kind of left this, left out this aspect, apart from mentioning that you very often find XML inside and people even don't know that it's XML. This includes, of course, docx. For most users, well, it's just called docx, and that's about it. They don't know that it's a zip file that has XML documents inside. So, of course, my own perspective on the history is a bit old school in the sense of visible markup as the primary representation of the document. And certainly other factors apply when perhaps the use of XML inside of such formats is governed by slightly different considerations because the end user doesn't see it, doesn't know it, and can't make a decision on that. And actually, in most cases, it's probably just it's mainly the application that counts. And if the application uses some formats, yeah, well, so users can't do anything about that. And that's why I left it apart, but it's certainly another issue as well in the bigger scheme of things.
Yeah, you're probably hungry, but George has something to say as well.
Yeah, so I think that the future of XML depends mainly on us that we are here. So basically we cannot just stay and hear something about the future of XML. We need to take that into our hands, basically. And from my point of view, the missing points are that we have the building blocks and we have some systems that work, but there are no, so between those bricks and the finished houses, there are no, let's say, blocks that quickly other have prefabricated things that you can just put together to quickly build something else. And there are a lot of us here that are consultants and that do, systems, but most of us maybe work for a customer and we build a fancy thing for them, but there are not readily available blocks that someone can just put together and build something interesting, So that's, in my opinion, the missing part. And we can do that. Right? Because all the power is already here in XML.
Okay, we will build XML bricks. Okay, I think it was last question because lunch is waiting for us, so thank you again.
Well, thank you.